David Can here with another question from your Hayes and Harris Math SL textbook. This is exercise 10I.1, question 2, parts A and I. Or is that an L? I think that's an L. In this question, we're asked to simplify these expressions. Now, these two expressions, to simplify them, we're going to rely on this identity, which tells us that the sine of an angle squared, the sine squared of an angle plus the cosine squared of that same angle is equal to 1. Now, this identity comes from the unit circle, and it also has to do with Pythagorean theorem. So if we take an arbitrary angle on the unit circle, let's maybe look at that one, which isn't meant to be any particular angle. It's just some arbitrary angle theta. If we look at the vertical component and the horizontal component and the hypotenuse, because this is the unit circle, the hypotenuse has to be the radius of the circle, and the radius of the circle is 1. That's the unit circle. The vertical component is going to be the sine of theta, and the horizontal component is going to be the cosine of theta. And from Pythagorean theorem, side squared plus side squared equals hypotenuse squared. Side squared plus side squared equals hypotenuse squared. And 1 squared is just 1. So that's the major identity here that we're going to take advantage of to simplify these two expressions. Here I have 3 in both terms, so I'm going to factorize out the 3, and I'll get sine squared of theta plus cosine squared of theta. Now I have my identity, sine squared of theta plus cosine squared of theta, which is equal to 1. So that's 3 times 1. Or just 3. And that's not too bad. Let's take a look at part B, or no, part L. Here I have cosine squared take 1. That is a manipulation of the relationship here. If I subtract 1 to the other side, subtract sine squared to the other side, I'll have cosine squared take 1 is equal to negative sine squared of theta. So bring the 1 across, bring sine squared across. And now I can say that cosine squared of theta take 1, cosine squared of theta take 1 is negative sine squared of theta. So that's negative sine squared of theta over negative sine of theta. So cosine squared of theta take 1 became negative sine squared of theta. Now I have sine on the top and the bottom. I can cancel, kind of. The issue is that I have 2 sines of theta on the top. I have sine of theta times sine of theta. That's what sine of theta squared means. So I can cancel, but I can only cancel one of the 2. The negative signs cancel as well. And this leaves me with just sine of theta.